So today's lesson was all about standard deviation, which we briefly had learned how to calculate before, because why not? When you're learning how to use Desmos, might as well learn how to calculate that. So hopefully we all know how to use technology to compute it. Desmos is going to be enabled on all your in-class tests, but it's not going to be on your state tests. So still highly recommend you get a graphing calculator, check one out from the store. There are ways to compute standard deviation on the calculator too. That is just as easy as when you use that. So, you know, never want to like just only use that one, also know how to use the graphing calculator. And then describe standard deviation as a measure of variability. So what does variability mean? Oh, yes, how spread out it is. So that's a really big one. Like you need to know standard deviation tells me how spread out something is. So when it says, like I'm thinking of a few test questions, you know, what does a standard deviation mean? You wouldn't say, like, say the standard deviation is, I don't know, 2. You wouldn't say that most of the values are 2. All right, that's not measuring how spread out it is. You could say on average, it is spread out by about 2 points each time, things like that. So that could be like a really easy test question, as long as you know standard deviation is how spread out something is. And what it means about certain situations, like, I don't know, when there's like those race car examples, like the ones we did in today when we were talking about like the salary of certain careers, knowing what that means. I feel like people kind of drew a blank when I asked that question. Let me go back to it in the notes. So when I said which graph looks like it has a standard deviation of about 10,000 or whatever the case may be, if that's my standard deviation for that career, we're saying that like while the central value is about 64,000, there's engineers that make about 74,000, 84,000, 94,000. And then in the other direction, like 54,000, 44,000. That's what we mean when we say it differs by about 10,000. Does that make sense? So then, when we're comparing the standard deviations, the business majors have the highest. Why do you think that is? Why do their salaries go from like 25,000 all the way up to like 95,000 on here? Like, what are some real world examples of that? Why do not all business majors make the same amount?
Some are higher ranked.
Because some are higher ranked than others. What do business majors usually do? Business. Like they usually own a business, but then there's also some that maybe do something else. Or maybe their business isn't as successful, like who knows? But they clearly have the higher standard deviation, so we're saying that the average salary is about 52,000, but there are some that make like 72,000, 92,000, and then in the other direction, 32,000. That's how much it differs on average. Questions on that? Okay, so when it says like, what does it mean when social science majors have a standard deviation of about 6,700? That means that each point differs by about that amount. How spread out it is. All right, so questions on that? All right. I don't think we got to it in the lesson, really, like it never really came up. But what other measure of spread is standard deviation most like? Is it closer to the MAD or the IQR? The MAD. Do we remember why? MAD, well, MAD is a measure of spread. but these are all measures of spread. But why are standard deviation and MAD more alike than like standard deviation and IQI? Yes.
They both measure the entire data. IQR includes the information.
Okay, good. So this looks at the entire data spread outness, where IQR just looks at the middle 50%. That is a good reason. Anyone know the other good reason? We might have talked about it briefly in lesson 6, but like we've never had to calculate it by hand, so maybe that's why you don't know. So let me show you again. So we talked about how MAD and mean have a relationship because they both use the mean when you're calculating it. Let me show you the formula for standard deviation. All right, it's a big long formula. That's why we don't even bother trying to make you calculate it by hand. It's a long process. In the past, when my students had to calculate it by hand, it would take like the entire day just to get one answer. So this symbol is standard deviation right here, in case you use a calculator and read it. All right, that symbol means standard deviation. This one means mean. It just looks funny. All right, so like MAD, the standard deviation uses the mean in its calculation. So now think of those hand in hand. Standard deviation, MAD, and mean, all in one group. And then what's the other group? Let me draw it out. This would all be one group because they all use the mean. What's the other group of like summary statistics we talked about? If we don't want to use the mean for our center, we use what instead? Okay, and then if we use the median per center, if we use the median per center, what do we use for spread? IQR. These are one group, and these are one group. When do I use the mean as my measure of center? Like when do we prefer the mean over the median? When the data is symmetric, we use the mean. So now add that to the group. When the data is not symmetric, that's when you use your median and IQR. So this is all one group. This is the other group. So come up with some sort of test strategy to remember it. I remember like SS and MM. I mean, I guess you could confuse this M with that, but it's mean absolute deviation, so I wouldn't confuse that. Then over here, these are like the leftovers. I don't know, come up with some sort of like mnemonic device for N, M, and I. Or like min, I don't know. Come up with something so that you remember this is one group and that's the other group. So questions on that? Okay, so then I'll give you some time to work on your practices from today. They are separate, but they are like combined no more than 9 problems. So that's your task for today. I'll check in a bit, but do let me know if you have questions as we go. Just the most missed one. All right, so the most missed one is this one. Hopefully you can't see anyone's answer. Okay. So we have which of these best estimates the standard deviation of points in a card game. So estimates, meaning like, I suppose since it's a dot plot, you could put it all in Desmos and know what it is exactly and see what it's closest to. But you don't even have to do that if you have a good understanding of standard deviation. So
based on how it's spread out, what would you guys say is like the best estimate for the standard deviation? Parker? 5? Anyone think something different? So why that is, we'll just look at it. Look at the tick marks. They're going up by 5s. There seems to be like a different amount of dots on each tick mark, but there's still dots there. So on average, they're deviating from the mean, which would be in the center since it's symmetrical. It's deviating from the mean on an average of 5. And if you're still not sure, these other ones are like just way too big. That would say that we're differing by an average of 20, basically. So there's no 520, there's no 540. So that would probably be the only one that makes sense. However, let's just kind of show you, just in case. All right, still pretty quick and easy to do. So if you have leftover time, like on a test, is when I would suggest this, but you can put your data points in and then actually calculate your standard deviation. So I have 1 490, 2 495s, 4 500s, 1 505, or 2 505s actually, and 1 510. I never know which one it's gonna do, whether it's the sample standard deviation or the population standard deviation. So I always just find both. And these ones, they're always gonna be pretty similar. And then out of my answer options, it's the closest to 5. So that makes sense. Questions on that? Any other requests from that practice? Keegan? Okay. 1 second. The mean of data set A. All right. Okay. So the mean of data set A is 43.5. Sorry if you can't see that from where you're at, but you should be able to pull it up on your practice too. But the mean is 43.5. The MAD is 3.7. The mean of data set B is 12.8, and that MAD is 4.1. So when it asks about which data set has greater variability, think about what they give you. They give you the mean and the MAD. Which one is the only one that tells you how spread out your data is? The mean or the MAD? The MAD. All right, by definition. This one's a measure of center. This one's a measure of spread / variability. And if that doesn't help you, maybe read this one and it kind of tells you. Blank shows greater variability because the MAD is greater than the MAD for blank. So which one has the greater MAD, A or B? B has the greater MAD. All right, A's MAD is 3.7, B's MAD is 4.1. That means B is more spread out. Does that make sense? So B will have greater variability because the MAD is greater than the MAD for A. Then it says, what differences would you expect to see when comparing the dot plots of the two data sets? So I can tell you even before we fill this part out. Since this one's more spread out, or higher MAD, it's going to be more spread out. So I can kind of like make a note of that if I want. More spread. And then it's always talking about in relation to the mean. So the mean of A is 43.5, so we should expect our dot plot to be around 43.5 for the numbers, and this one around 12.8 for that mean. Okay, so in that case, fill in the blanks. A's dot plot will have most of the data centered around 3.7 or 43.5. Good. So that would be like our typical values. So good.
on average, length units above or below. So 3.7 or 43.5. Okay, so 3.7 units above or below what? 3.7 or 43? 43.5. So, and I do this too, like when I, would curve a test, by the way, I would find the mean of that test score. So say my mean is like, I don't know, 60%. I would find my standard deviation and say the standard deviation is 20. So then that means that while my mean is 60, the next score below that would be 40, and the next score above that would be 80, and then I would like bell curve it down. So I do use those like in the real quick. But yeah, so we're saying that on average, this will differ 3.7 above and below 43.5. Then now do the same with data set B. Most of the data centered around that mean, which is what? With the data on average, how many units above or below? And then above or below what? Okay, good. So that's all knowing your measures of center versus spread. Any questions on that? Any other questions on this 12? I'll check back in on the 13 practice once I have a few submissions of those. So we could see which ones people are having the most trouble with. But if you have questions prior to that, let me know. Also, even though there's like 4 problems, 80% is still the goal. So, if you need another attempt, you can ask. I kind of give them when I see them, but like, it's probably better that you ask. So this one is the most missed one. And it says, it's a long one. So we have 3 drivers competed in the same 15 drag races, and the mean and standard deviation for the race times of each of the drivers are given. So here's all of that information. We'll use it in a second. So for who had the fastest typical race time? Anytime we're talking about a typical value, does that mean like center or spread? Good, so you should be looking at the mean then, not the standard deviation. So in that case, who had the fastest typical race time? You would think, if that's their race time, are they the fastest? That means they took the longest, right? So the fastest is actually who? B. So also knowing that too, like, if they're the fastest and they have the smallest amount of time. Which driver's race times were the most variable? So anytime it says variable, is that center or spread? Spread. So now look at standard deviation. Who had the highest standard deviation, the most spread? Okay, so good. Now, what driver do you predict will win the next drag race? I feel like that's open to interpretation, but they do say use the mean and the standard deviation. So, and I feel like this would be justified in a number of different ways. What did you guys say? Okay, so let's see. B has the shortest time, but like the second most variable time. So he's less consistent than say like driver A, but driver A also takes the longest. But let's see what the rest says. Even though the driver's mean race time is between the other two, so that has to be driver B then. That's who we're talking about, between the other two. Driver B, or sorry, who shows more variability? C. So even though B is between the other two race times, C shows more variability. That means the driver is relatively slow, but sometimes relatively fast. Okay? So even though his mean is like. Yeah. Hold on, is it marking it right if you put that?
It marked her too.
Okay, cause now that I'm reading it again, it says even though the driver's mean race time is between the other two. This race time is between the other two, so I think it has to be C, sorry. I can unsubmit it. So, cause that would make more sense, if this driver's race time is between the other two, see that? Okay, and then that means driver speed shows more variability. Sometimes goes slow, then fast. Let me look at it. If you need me to put another attempt, email me, cause I might lose track. But let me freeze this, so you can't see the scores. Okay. So yeah, if you need me to unsubmit, just let me know through email, cause the bell's gonna ring any second, just be like. I need you to unsubmit 13, and I will get to it when I have a moment. Question, Keegan?